Analysis of variance, Anova, is a collection of statistical models used in order to analyze the difference between group means and their associated procedures, such as variation among and between groups. For example, if a sample finds that the average number of cups of coffee consumed per day by freshmen during finals is 3.7, while the average number of cups of coffee consumed per day by seniors and graduate students is 4.3 and 5.1 cups, respectively, are these observed differences statistically significant?
The term one-way ANOVA is used since there is only one independent variable. An example of ANOVA problem may be comparing three drinkers of Starbucks coffee, light, medium, or heavy users, and their attitudes toward a particular Starbucks advertisement campaign. In this case, there's only one independent variable, which is the consumption of Starbucks coffee, but it's divided into three different levels, which is light, medium, and heavy users.
Okay, the null hypothesis for ANOVA always states that there is no difference between the dependent variable groups. In this situation, the ad campaign attitudes the groups of Starbucks coffee drinkers.
For example, suppose the heavy users of Starbucks coffee rate the advertisement campaign 4.4 on a 5-point scale, with 5 equal to very favorable. The medium users of Starbucks coffee rate the campaign 3.9, and the light users of Starbucks coffee rate the campaign 2.5. The F-test in Anova tells us if these observable differences are meaningful.
So the larger the difference in the variance between groups, the larger the F ratio, and the larger the F ratio is, the more likely it is that the null hypothesis will be rejected.
In our example of Starbucks coffee drinkers' attitudes towards the advertising campaign, we could conclude that differences in attitudes toward the advertising campaign exist among light, medium, and heavy coffee drinkers, but we would not be able to determine if the differences are between light and medium, between light and heavy, or between medium and heavy, and so on. We would be able to say that there are only significant differences somewhere among the groups.
The purpose of the ANOVA analysis is to see the differences that do exist are statistically significant. To examine the difference, an F ratio is used. The larger the F ratio, the more difference there is among the means of various groups with respect to the likelihood to recommend the restaurant. Note that this application of ANOVA examines two groups: the two restaurant competitors Santa Fe Grill and Jose Southern Western Cafe. But ANOVA can be used with 3, 4, or more groups to identify statistical differences if they exist. This tells the SPSS to statistically test the difference in the responses on the three variables selected. In the top of the table, there are comparisons of males and they differ only in one variable, X24, the likelihood to recommend the restaurant. That is, the mean perception of male between the two restaurants do not differ significantly in satisfaction or likelihood of returning, but the male customer of Santa Fe Grill are more likely to recommend the restaurant with a mean equal to 3.78 than are the males customers of Joseph Southwestern Cafe with a mean of 3.23.
So, for example, a marketer may be interested in finding out whether consumers prefer a humorous ad to a serious one, and whether that preference varies across gender. Each type of ad could be shown to a different set of groups of customers, both male and female. Then questions could be asked about their preferences for the ad, and the product it advertised could be asked. Primary difference between the groups would be a difference in ad execution, whether it's humorous or non-humorous, and customer gender. And then finally, an N-way OVA could be used to find out whether the ad execution differences helped cause differences in ad and product preferences, as well as what effects might be attributable to customer gender.